so what we're talking about today kind of goes with our study of chemical reactions. We listed some signs of what a chemical reaction might be indicated by: color change, odor change, bubbles, temperature change is what we are focusing on today. And that's why we have these little pictures up here of the faucets that are hot and cold. And the title of the PowerPoint, Endo and Exo, we're going to get into what that is a little bit later. Those are going to be our new vocab words for today. So most of this we already talked about when we did our little demonstration. If we were looking for a chemical change, we might see things like bubbles. We might see things like a precipitate. Who remembers what a precipitate is? Yeah. Solid stuff that forms in usually two solutions that are mixed together. The other way you know that you have a precipitate might be that the solution turned cloudy. Oh, we forgot to mention this one. If something burns, that would be a chemical reaction. Changes color, we named that one. That's usually the one that people think of first. And changes temperature, which is the one that we're focusing on today. We're going to talk more about how those, how that heat is transferred from one thing to another, and what words we can use to describe that change. So a change in temperature could be the reaction getting hot, like you saw in your lab last week with the acid in the hood. Some of those got very warm very quickly. Or it could be that the reaction is getting cold, like the one that we did today. Okay, here's the other thing we're going to review before we get to the new stuff. We have a test Friday, it's a good thing to review anyways. Physical changes occur when? What are some examples of physical changes? Freezing. What else? Melting. Evaporation. We're going with phase changes so far. There are 6 of those and you have 3. Do you remember the others? Condensation. Oh, now we're just missing the 2 hard ones. If it goes from a solid to a gas, that is, this is what dry ice does. Starts with an S. Sublime. And then back the other direction, starts with a D. Deposit. Very good. Got them all. Remember we talked about a couple weeks ago, physical changes could also be something as simple as ripping a piece of paper or breaking a piece of glassware. We are going to focus more on those 6 phase changes that you just named. But as a little bit of review, the substance is still the same substance when you have a physical change. It has not formed into anything new, so it's still the same substance you started with. And these are those 6 phase changes that we just listed together. You still have the same substance after the change is done. The only thing that you have changed is the phase or the form or the state of that substance. And these are those 6 phase changes that we need to know for our test on Friday. Melting, evaporating, subliming or sublimating, freezing, condensing, and depositing. If you're going to make these phase changes occur, let's take a couple of them that we're pretty familiar with. Melting and freezing. If you want to melt an ice cube, what do you have to do to it? Heat it up. If you want to freeze water, what do you have to do to it? Cool it down. So in any of these 6 phase changes, and it's very easy to see it with the 2 that we're most familiar with, but in any of these 6 phase changes, there also has to be a temperature change. If you're going to change the phase of a substance, you have to change its temperature. Like if you're going to melt an ice cube, you have to warm it up. You have to change its temperature. So it turns out that in both chemical changes and physical changes, it's possible that we might be dealing with a temperature change. In both physical and chemical changes, there can be a flow of heat between what we call the system and the surroundings. In other words, there's a temperature change. There's some heat moving from one substance to another. There can be a flow of heat between the system and the surroundings. So what are the system and the surroundings? What do we mean by those two words? The system is the part of the universe that we're looking at or that we are focusing on. The system is what we're looking at. The system is what we're focusing on. This could be a reaction in a test tube, or an ice cube that's melting, or the reaction that was taking place in that little beaker that you saw this morning. And the surroundings then would be everything else. You could include, really, the entire universe in the surroundings, although we usually don't. Usually it's more practical just for us to think about the things that are right next to the system, or right next to the part that's changing. So the system is what you're looking at. The system is what's doing the changing or doing the reaction. The surroundings then are everything else. But usually we only think about what's right next to the system. So for example, what would be right next to the system in the demonstration you saw would be the beaker. Your hands, as they touch the side of the beaker, would have been part of the surroundings. The wood block underneath the beaker was part of the surroundings. If you're trying to melt an ice cube and you're standing there holding it in your hand would be the surroundings. So heat can flow two different directions. It's pretty simple, two different directions. Heat can flow into the system or out of the system. Heat can flow in or it can flow out. We use two words to describe the direction of heat flow, whether it's flowing in or flowing out. And these are the two words that were the title of the PowerPoint. These are our two big vocab words for today. First one is exothermic. Exothermic. What do you think the first part of that word sounds like or means? Exo. An exit. Or if you're thinking about bugs, exoskeleton, which means they wear their bones on the outside of their body. Or an exit means to leave the building. Exothermic, exo means outside, and the thermic part usually refers to heat. So when you put those two things together, this is the change that describes heat that is leaving the system. Exothermic changes are those in which heat is given off from the system. Another way to say that would be heat flowing out of the system. Heat is given off, heat is exiting, heat is flowing out. If there is heat flowing out of the system, where does it go? To the surroundings. So if there is heat going to the surroundings, like your hands holding a beaker or a test tube, what are you going to feel? Hot. If the heat goes to the surroundings, exothermic changes are typically those that feel hot. The surroundings heat up. Endothermic, you could probably guess, is going to be just the opposite. Because endo doesn't sound like an exit, it sounds like an entrance. Endothermic, like an entrance, those are the changes that describe heat going in to the system. Endo means within. Thermic, of course, still refers to heat. So an endothermic change is one in which heat is absorbed from the surroundings. In other words, heat is flowing in to the system. If heat is flowing into the system, where does it come from? That heat's got to come from somewhere. The surroundings. It's got to come from the surroundings. If your hands are the surroundings and the heat is being taken from them, what do you feel? Cold. The heat comes from the surroundings, it goes into the system. That means that the surroundings are going to feel cold. Surroundings will cool down or feel cold. So now that you know this, which one did we have for our demonstration today? Endo or exo? Endo, because it felt cold. Hopefully you found that question I just asked pretty easy to answer. How do you tell if a chemical change is endo or exo? Well, you feel it for a temperature change, and then you decide. If it feels hot, it's an exothermic change. If it feels cold, it's an endothermic change. That's pretty easy. But this only works for chemical changes. Physical changes can be trickier to determine, especially phase changes, those 6 things that we listed earlier. Phase changes can be much harder to think about. Is it going to be an exothermic change, or is it going to be an endothermic change? And that has a lot to do with how we perceive those changes, or what we think is happening in those changes. So in order to understand which phase changes are going to be endo and which ones are going to be exo, we need to review some things that we know about states of matter, atoms, and molecules in those states of matter. So what are the 3 states of matter all together now? Solid, liquid, and gas. We're not worrying about plasma today. No plasma in here. If you have a solid, you have atoms that are fixed in place and they are very close together. I usually use the comparison that students in their desks on note-taking days are like a solid. If each of you was an atom, stuck in your desk in a nice, neat, orderly pattern. You're very close together. You can't move a whole lot. Usually that means you're pretty low in energy. You can wiggle a little bit, but that's true about atoms too. We'll talk about that later in the year. Pretty low energy today. Just taking notes. That would be solid. In a liquid, the atoms can move a little bit. They're still pretty close together, but they can kind of slide around past each other. This would be like students on lab days. You can move through the back of the room from station to station, wherever you need to go. You're still pretty close together and you're still kind of contained. In a gas, atoms can move a lot and they are very far apart. So this would kind of be like students at 3 o'clock when you hit the front door. Everybody scatters to the four winds as far away as you can get. And you have lots of energy then too. Yeah, wonder why. We need to understand how the atoms are arranged in each of these three states if we're going to be able to put our 6 phase changes into either an exo category or an endo category. It's going to be important to think about what the atoms are doing or how they are being rearranged, if you will, during a phase change. So the examples of the phase changes, of course, we listed them already. Melting and freezing, evaporating and condensing, sublimating and depositing. Notice how I kind of read them in pairs. Each phase change has like an opposite pair, so freezing and melting go together. Condensing and sublimating, or condensing and evaporating go together, I'm sorry. Sublimating and depositing go together. Each phase change has like an opposite partner. We are going to take 3 of those partners and put them together into a category. Each phase change has an opposite partner. We're picking the 3 partners that are all very similar in what they do. So the first group of 3 is going to include melting, evaporating, and sublimating. In all of these changes, we are pulling the atoms away from each other. In all of these changes, the atoms were closer before the change and further apart after the change. I'm going to let you call that breaking bonds, although we're not technically breaking bonds. We'll talk about that later in the year too, but that's the easiest way to think about it for right now. In all 3 of these changes, you're pulling the atoms apart from each other. They're going to be separated by more space after the change. Does that make sense? Think about a solid. A solid, you're all really close together, you're locked in place, and then a liquid, you can separate a little bit and move a little bit more. If you go from a liquid to a gas, you're still pretty close in a liquid, and then in a gas, they're way far apart. So all of those atoms are pulling apart from each other, and we're going to call that breaking bonds. This increases the ability of the molecules or atoms to move more freely. If they are farther apart, they can move more. This also results in an increase in their energy, just like you. The more I let you move, the higher energy you have. Here's how we're going to tie this to endo and exo. If you would like to pull bonds apart, you must put energy into the system to do that. And the example that I usually use is just a real simple pair of magnets. If these magnets are atoms that are bonded together, do they fall apart by themselves? No. If I want them to come apart, I have to put energy in to do that. Ooh, you laughed. it does take some energy, not very much, because these are just magnets, but it does take some energy on my part to pull these atoms away from each other. To pull bonds apart, you must put energy into the system. If you are putting energy in, that change is endothermic. One other quick way to think about that. If you want these three changes to occur, if you want to melt the ice cube, you have to put heat in. You told me that already. If you want to melt the ice cube, you warm it up. You put heat in. If you want to make water evaporate faster, think about rain puddles. They're going to evaporate faster when it's hot outside, when it's sunny outside. There's more heat going into that system. The other three are, of course, the opposite. You could probably fill these in on your own, even without me explaining it to you. Freezing, condensing, and depositing, we're going to be forming bonds. Again, bonds isn't quite the right word to use here, but it is the easiest one to use for now. All three of these changes decrease the ability of molecules or atoms to move freely. They're more restricted after the change. Which results in a decrease in energy. Like when I make you sit in those desks for 42 minutes. This energy has to go somewhere. So it goes out of the system as the bonds form, and it would be picked up by the surroundings then. Energy is given off from the system. If energy is leaving or exiting the system, then these are exothermic changes. And this is where we get confused. This is where it's easy to mix up the difference between chemical changes and physical changes. Because if I asked you about freezing water, you would associate that with something that's cold, right? But you are making it colder. You are taking its heat away to freeze it. That makes it an exothermic change. If you have to take heat out to make that change occur, then it's an exothermic change. Okay, so here is a little word to help you remember which phase changes are endo and which phase changes are exo. The word is BARF. Yum, yum. B stands for breaking bonds. When those bonds are broken, energy is absorbed. That means it goes in.
Is that E on the bottom?
For energy, yep.
Oh, okay.
Absorbed energy. The E is for energy. Now we got to start at the other end of the word. The F stands for forming bonds. When bonds are formed, energy is released or given off. And again, that E at the bottom stands for energy. So when you're thinking about your 6 phase changes, you have to think about, are we making bonds or breaking bonds? Broken or formed? If bonds are being broken, energy's going in, those are endothermic changes. If bonds are being formed, energy is coming out, those are exothermic changes. I have one more diagram to help you remember which 3 phase changes are endo and which 3 phase changes are exo. We have 3 boxes here. You could probably guess that the 3 phases go in the 3 boxes. So we have a solid, a liquid, and a gas. And I put little pictures next to them to remind myself what those atoms and molecules are doing. In a solid, the atoms are very close together. They're locked into place. A nice, neat, orderly pattern. Solids hold their own shape and have a definite volume. Liquids, atoms are still pretty close, a little bit more randomly arranged. They can slide past each other. Liquids have to take the shape of their container, so that's why they're in a cup. But they do have a definite volume. Gases, of course, are much more spread apart than that. Lots of space between the atoms or molecules, very randomly arranged, lots of freedom to move. They have a variable volume and a variable shape. That's why it's in a balloon. Okay, what's the change from a solid to a liquid? Tell me quick. Solid to liquid? Melting. Back the other direction would be freezing. Gas to liquid. Condensing. Make sure you know these for Friday. Back the other direction would be evaporating. And the 2 that are the hardest to remember, solid to gas is sublimation. Gas to solid is deposition. Underneath, we're going to put just a couple things about this diagram. Hopefully you got all your words on the right arrows because it does make a difference. All of those inside arrows are exothermic. All of those outside arrows are endothermic.